Okay, here's a look at what we'll be doing today. I'm a fan of parry mechanics. I like the game Lies of P. I enjoyed the parrying aspect in Expedition 33, uh, Prince of Persia. I love all that stuff. So I wanted to figure out how would I go about doing that? How would I have the engine know that it's a regular block versus a perfect block? How would I change stamina, or how would I implement code based on hitting block at the correct time? So that's what I'm doing here, and if that's something you want to learn about, stick around. Let's get right into it. Also, just a quick disclaimer, I wasn't able to record when I was creating this code, so this is going to be a little bit different of a tutorial. The code's already all done, so I'm just going to kind of go over the nodes that I'm using rather than a step-by-step tutorial. I think you'll still be able to follow along and do this. I mean, recreate the code. But I just wanted to kind of give you give you a heads up that it's not the normal step-by-step. I create this node, then I create the variable and I drag it out and show you all that stuff. All right. Instead, the code's already created, and I'm just gonna kind of go over it. Okay, so we'll start with the attack. In the attack montage, I have created a anim notify state, and it has a beginning and an end. That's the difference between an anim notify state and a regular anim notify. So if you go to Blueprint class and search for anim notify state, you will find that, and just go ahead and hit select to create it. And if you open it up, if you go to function override, you can see receive notify tick, receive notify end, begin. So we are working with the end and the begin. Okay. So from the receive notify begin, we have a mesh comp that goes into a world context object that creates a widget, and we add that widget to the viewport from the return value. And from the widget return value, we're getting a random identifier. That's a variable I created within the widget. And then going forward, we have a interface being called, and we're using the mesh comp. It's a variable that is created with this notify, and from that we're getting the owner, and with that owner we are initializing the interface. And then we're using the player character to be the blocking actor. Okay, so let's take a look at this widget real quick. This is a widget just for me that I've created to let the player know when to try to block. And it appears when the NPC is attacking. And you can create that variable just by going to the left there. And this variable is just getting a random float in a range between 0 and a big number. And I'm doing this, if you don't want a way to notify the player that it's time to block, you don't need to create a widget or anything like this. And the reason I'm using a variable from the widget is because you cannot set values inside of this notify state. Okay, so you have to figure out another way to get set values from here back. You set a value from here and then get it back when you are at the receive notify end. So let's take a look at the interface. Right now this is just the begin function. And in interface, you go to blueprint and blueprint interface. And an interface is just a storage of functions that there is no implementation in the interface alone. You attach it to an actor blueprint and you implement the interface from there. All right, this just stores values. All right, and as you can see, the blocking actor, I'm storing the actor, not the sandbox character, because I don't want any hard references to blueprints that have a lot of data in them. And so I don't want to go and find the specific actor blueprint class. I just need the actor class, and I can implement the interface just from that. And this is the interface that's going on the NPC, so it's a little bit less important on the NPC interface because, you know, the player character is basically always loaded. You know, if you're playing, you're loaded. It becomes more important when you're using an interface on the player and you have functions. You don't want those player functions to have hard references to specific NPCs and enemies, because that player is going to have to load all that data when the player character is loaded. For example, you could load NPCs that aren't even on the map, or enemies that aren't even on the map, if you make a hard reference to a specific blueprint type here. So that's why I'm just using actor. An actor can implement any interface, and then from there you do specific implementations for that enemy or NPC. And I'm also grabbing a float for the block identifier, and you can add inputs just by hitting that plus button. Okay, to implement an interface on your character, what you do is you go to your class settings on the top, and then once that is selected, on the right you go down to implement interfaces and you select add, and you just select the interface that way. All right, and you can implement multiple interfaces. All right, and we'll take a look at the other functions later. And then from that, we are returning the node. All right. So this end, we're just getting the blocking actor, which we're not actually going to use in this. And then we also have get block widget identifier, and that is an output only. An output on a function in an interface will create a function inside of your actor when you use it. And I'll show you what that means later. So now let's go to receive notify end. Take a look at what's going on here. So as you can see, this diamond right here at frame 10, that's the end. So that's when this code will be called. So from the mesh comp, we are getting the owner of the animation, and from that we're implementing the interface and calling the function get block widget identifier. All right, so that's getting. If we go into our enemy character, you can see that this is that event perfect block is being implemented here, and from there we are storing the block widget float, and we just have that here on the left as a float variable that I created, and we're getting whatever that widget random number was, and we're storing it here because we're going to call it again when the begin notify end tick is implemented inside the anim notify state right here. Right, so in receive notify end, that's when we're implementing this, and we're getting this block widget and identifier that way. And then you can see this interface, get block widget identifier. This is what I was talking about when it creates a function. So you see the other function only had an input, so it created basically a custom event using that function, whereas this one has an output. So instead of creating a custom event on the event graph, this will create a function because it has an output. And we're outputting the stored widget float that we just got from the perfect block begin, and now we're using that variable to output that value with our function on the interface. That's what's happening here, and we're setting that as a variable. We're promoting that value to a local variable because regular variables cannot be set, like I was saying before. So we cannot set a normal variable here. We have to use a local variable. And as you can see, if we go from notify end to notify begin, that local variable is gone. So the local variable will only stay on this receive notify end function. That's why we had to go out of our way to get that random identifier to our enemy and then back here. All right, so now what we're doing is we're getting our mesh comp, and that is going into our world context object for our widget of class, get all widgets of class. and we're going to go through all the widgets because we might have multiple enemies attacking us right now. So we want to make sure that we remove the correct identifier, the correct widget. And that's why I went to do this. So we're getting all the widgets. We're seeing if there's more than one, and if there are, we're going to check this widget against the random identifier that was created when the enemy started attacking us. All right, and to get that, you can just use the array element, and from that you can get random identifier, or you can get any variable you have stored on that widget. And then this identifier, we're just grabbing the local variable identifier, and we're just getting. Okay, and then if they're equal, if that's true, we're going to check if the widget's valid, and if it is, we're going to remove it from the parent, remove it from the screen. And then once that's completed, we're going to initiate the interface and function perfect block check end, which we go forward and it is right here in the code. So essentially, and I'll talk about this code a little bit longer, but we're running a timer through frames 5 and 10 to check if our player is going to hit the block button. All right. So this is what we're doing. When that diamond strikes at the beginning at frame 5 in that animation, this is what happens. We're checking to see. What we're doing is we're casting to our sandbox character, and from that we're getting some variables. Well, right now we're just getting is blocking. So if our character is already holding down, the block button, if that's true, we're going to go into a basic block and we're going to drain some stamina, because a perfect block essentially is you only hit block after the attack has started. If you're holding down block before the attack has started, you're going to lose stamina because you didn't time it correctly, essentially. I also have an and. If this enemy is already being blocked, if he's not being blocked, then we'll go forward with a. I'm not so sure this is important. This is not really utilized in this, but essentially we don't want the code to fire if he's already being blocked. So I almost could set another branch here and saying if I'm being blocked, if I'm not being blocked, if that's true, go forward with the code, and then go into the branch that checks if you're blocking. And if I am being blocked, then don't do anything. So that's probably what I should have done here. But for now, we're just talking about is blocking essentially. So if we are blocking, if that's true, if the character's already holding down the block button, then we're going to go forward with this true code, and that we're going to negate some stamina from our player. And so what we can do is we can just get our player character, and from that we run the basic block function that's using another interface on the player, and we're going to drain stamina, which is just another float I did, and I gave it a value of 15, so it's going to drain 15 stamina. I made that instance editable, so you could change that based on the enemy that's attacking. So if it's a boss or something, you could drain more stamina if you like. So what I'm doing is I'm using the Paragon character in this. Obviously Quang, he's a Paragon character, and in the Paragon characters they have this combo code already set up. So if you haven't messed with the Paragon characters, I suggest doing that. But what's happening here, I just wanted to show you real quick, is this is important for when you're doing the blocking animations or was blocked animation montages. This attack count is a integer that's storing where we're at in the combo. And it goes into a switch on int, it checks what it is, and if it's 0, it's going to initiate the first attack in the combo. But before that, it changes the attack count to 1. So when the enemy is using the first attack in the combo, when the montage is actually playing, the attack count is 1, not 0, because it gets updated before that. So when we're doing our actual block animations, see 0 is what the value is when we're doing our final montage in the combo. So when we're playing our block animations, we have to, when it's 0, we're going to play the last montage first, and then when it's 1, we do the first attack in the combo, a third or second block in the combo, and so forth. All right. So that's just something to keep in mind. So off the execution pin, immediately after the montage plays, this is before it's completed or interrupted, we're going to set being blocked to true. And then we're going to play a custom event on our protagonist, our player character, that pushes back our player just a little bit. They were blocked, so we're just going to slide them back just a little bit. And we do that with the root. I just had the root go back a little bit, and that's off the execution immediately after this node is played. That will do that, and then from completed and interrupted, once the montage is completed or interrupted, then we're going to end being blocked, and we're going to save the attack. This is important because we want the enemy to keep going forward in their combo. We won't want to reset the combo. So if the attack montage that they're using gets interrupted, it won't save the attack because in those attack montages, there's a save attack and reset attack. So if this, and as you notice, the anim notify state reaches ends before the combo save attack. So basically that montage is interrupted before it gets a chance to save the combo, and so that's why we gotta save it here so that the enemy can move forward with their combo. Otherwise they might just stop attacking. They'll hit 1 and then nothing will be reset or saved, and then it might just break that code. So that's why we gotta put this combo save attack here to reinitialize it. And we do a lot of the same stuff with the perfect block, but we do some things before that. So if our player is not blocking, then we're going to go through and we're going to do a set timer by event. That timer is going to be cleared and invalidated when the event perfect block check end function is called. And that is called again from the notify end inside of the anim notify state. All right, so when it hits the end of that anim notify state, that event perfect block is going to be initiated, and it's going to clear this timer by event, and it's also going to set perfect block to false. So you only have your opportunity to use the code from this event that is initiated by the timer. You're only going to be able to do that code in that short 5-frame anim notify state duration. All right, and you can extend that duration on your notify state to make it more forgiving for your player. What you want to make sure though is that it ends before the save attack is initiated inside of that montage, because that will break the code. The NPC will move forward with the attacks, and it will conflict with this code, and everything will break down if that notify state doesn't end before the save tack. I have set the timer to loop every 0.01 seconds, and it will do it for the duration of the anim notify state. And to create an event from this timer, you can just drag off of this event little red square, and you can add custom event right there. Okay, but I already have mine, so I'm just going to delete this custom event and then reattach the check for perfect block. All right, and again, we're able to cast here. I'm not using an interface because, well, this for me is I'm only using this code when I'm attacking the player. All right, so the player is already loaded, and that's why it doesn't matter if I'm casting. Okay, so from here we're checking is blocking now. Okay, so now if it's true, that means we've hit it at the right time, and we're going to set perfect block to true. Though we don't actually use I don't use that variable in this video, so you might not need that. And then from that we do once, because I only want the benefits from this perfect block to happen once. That could be regaining health, that could be storing a counter amount of perfect blocks I've done in a row or something, and I only want that benefit to happen once. So we're going to do a once node, and then from that we're getting we're going to spawn an emitter, and then we're going to do a camera shake, and then we're going to play a sound. Now, the reason I have all this code happening here rather than on the actual animation is because I'm using the same pushback block montage that for a perfect block as I do for a regular block, and that's why I didn't put all these particle plays and sound effects inside of that montage, because I only wanted it to play here. So what I could do is I could have it play another montage. I could have a separate montage for perfect blocks and then put the sound effects and particle effects in there as notifies. But just for the purposes of this video, I didn't do that, and I'm just showing it right here inside of the actual event graph. So from here, basically the code is kind of the same as the perfect block. I'm going through the switch on int, and then I'm going down and I'm playing block montages based on where I'm at in the attack count. And I forgot to put perfect block to end. So when that is ended or interrupted, we are going to set being blocked. We're going to set being blocked to false, perfect block to false, and we're going to combo save attack. That way they can go forward with their attack combo. Now, I would do this for a boss, especially like in Lies of P, where you have bosses that you get blocked and then you move forward. You can also do a reset combo though. Say it's just like a regular NPC, and say you want the combo to be interrupted if you get a perfect block. What you can do is, instead of attack combo save, you can run the reset combo custom event, and that will reset the combo, and then they'll start from the beginning of the combo. So you would just run that to that instead. Okay, so this is off of immediately after the montage plays. What we do is we play the block montage. So we get our protagonist and we play that custom event, and then we do a small delay. And then we reset the do once node so that we can do another perfect. The delay, you want to make sure that it's shorter than it would take to do the second attack, so just keep that in mind. But yeah, this will reset it, so then you can do a second perfect block. If the delay is too long, then you get into a situation where the next attack happens and you're not going to be able to block it. So you want to make sure that 0.2 actually might be a little too long, honestly. Sometimes, I don't know, like attacks can happen pretty quick. So that's just something to think about. Okay, so we are getting our player character and we're casting to the sandbox character, and we're just doing that, and we're just getting the location, and that's where we're spawning the camera shake. The camera shake node play world camera shake. It has the epicenter, and I'm having that be the character's location. You can also make it the camera location if you want. The inner radius can be 0. I just put it at 1. But the inner radius and the outer radius, that's where the camera shake plays. So anything greater than 1 to 500, that's where it shakes. So if your inner radius was like 300, anything inside that won't shake, and then 300 to 500 shakes. Okay? So if we go inside the camera shake actor, and we open up the blueprint, these are the values that I'm using. It's a Perlin noise camera shake pattern, and I'm changed just the location amplitude and location frequency multiplier. I changed those to those values that you see, and then I changed rotation, the multiplier and frequency, and then I changed the duration. I left everything else the same. I am using the camera shake default camera shake base. That's what I used. And the difference between that and the one above that is that this one has the Perlin noise camera shake pattern already chosen. Okay. So this basic block is is for the player character. So I have that implemented in the player character. And the basic block is just getting our current stamina, which is a variable I created in this blueprint, and then it's subtracting the stamina removed, which was the 15 value that the enemy has. So I just have my current stamina and my max stamina. So I'm setting my max stamina to whatever value is subtracted. And you can see here, if my current stamina is less than 0, I'm not able to block. So this is what the animation blueprint is looking for. So this is what's happening here is if we're blocking, if we hit the block input, triggered, fires like basically on tick. So as long as you're holding that down, it's going to be blocking, and it's checking per tick basically if the current stamina is less than 0. So if you're holding down the block button and your stamina drops to 0 or below, it's automatically going to check for that, and then it's going to set your blocking to false, what's going to take you out of your blocking stance. Okay, so that's what's happening here. If it's not less than 0, if that's true, we're going to set the blocking, and we're going to reset the combo. But we want to reset that, so we start from the beginning of our combo. And then when we complete it is when we take our finger off of the input. That will set us to not blocking as well. And for the input, what I did is I duplicated jump because it's a digital bool. It's not an access bool, so you wanna have a digital bool for your block button. I'm using F and left shoulder. But yeah, you don't want that to be an access input. You want it to be a digital input. And that code you saw below is just for me in this instant is to add stamina. You know, obviously in your game you're gonna want some kind of probably per tick where you're gaining stamina over time. In this tutorial, I just have a number pad plus, and that will give me my stamina back so I could test it. And I have the blocking and attacking. I have the blocking on the base sandbox character. Um, if the variables were on the child class of the sandbox character inside of this animation blueprint, I would have to cast to the protagonist or the child class, and I don't want to have to do that. And so that's why I'm putting all these values that manipulate the actual animation blueprint on the base class, because this sandbox character is already referenced in that, and I don't have to create a new variable where I'm casting to my child class and then saving that as a reference. So coming off the event blueprint update animation, we're checking if the character is valid, and if it's valid, we're going to update our character-driven variables. I have this outside of this, and I'm going to move it back in here because this is where you update the variables. So I'm just going to go ahead and, rather than have it be a sequence and do this separately, I'm just going to get rid of that. I'm going to cut that, delete the sequence, go right back into this, and then I'm going to open up my update character variables function, and I'm just going to I'm going to paste those values in here, and I'm just going to update it here where everything else is updated. All right, and this is just grabbing the is blocking variable from our character reference, and then it's promoting it to a variable for the animation blueprint. Same with his attacking. Okay, so I'm blocking, and that's what it does. Okay, so now let's take a look at the animation graph inside the animation blueprint. I'm going to clean this up for a little bit, but basically all my blocking and attacking is done with the upper slot, and so I want to save that upper slot as its own kind of cache. And so basically all the code up to here is saved as a main cache, and you can do that by new save cache pose. So I cache all that code up to this point to save that, and then I call it again just by typing in main cache, and then I have that go through the default slot, the upper slot, and then I cache that again too. So this is for so that when we're using montages that use that slot, I'm caching it for that so that we can blend that with other animations later on. But this upper body cache is going into a blend poses by bool node, and it's if I'm not blocking, I'm going to just play my main animation blueprint code, and if I am blocking, I'm going to play this block animation. Okay, so let me go ahead and clean this up a little bit so it's easier to read. And then I'm caching that as well, actually, but I'll clean this up a little bit. All right, so if we're not blocking, we play the normal cache code, and if we are blocking, we're going to play that block animation, and then we're going to cache that as a block attack cache. And then what we're going to do is we're just going to do another blend poses by bool based on velocity. So if we're moving, we will negate legs, and if we're not moving, we will use the blocking animation's legs. Okay, so we don't want the blocking stance when we're running, so that's what this is doing. All right. So as you can see, these are all the same nodes: main cache, block cache, main cache, block cache, layer blend per bone, layer blend per bone. It's the exact same code. It's just if we're moving, we're going to use our legs, and if we aren't moving, we aren't going to use our legs. And these essential values, this velocity is updated in our essential values, and if it's greater, essentially if the value is greater than 5, the velocity is, we have velocity. So that's what that's checking for you. If you want it to be lowered, you would change it there. So this layer blend per bone is if we have velocity. If that's true, we are going to go to the layer setup, and we're going to add some branch filters. So I have pelvis in the thighs and the neck. And the blend depth for the pelvis is 2. That means 2 bones removed from the pelvis. I'm going to start the animation. So this blocking animation is going to play from spine 2 and up, or its children. Spine 2 and its children. And then what I'm doing is I'm negating the thighs. -1 will negate it, so the animation will not play on those legs. And it's also not playing on the neck, so the player can continue to look around with the camera. So the only difference on this one is I'm not negating the legs, and I'm putting the pelvis depth to 0, so essentially plays out from the pelvis. And that will give you the full stance. It essentially plays the full animation except for the head, where it still allows you to look around. All right, so if I'm not attacking and if I'm not blocking, it's not going to play any of that. It's just going to play the main cache pose. It's going to play the normal animation blueprint code. But if I am blocking or if I'm attacking, then it's going to use all this code I just went through. So if I'm not blocking, I'm not attacking, it's going to ignore all of this code. And if I am blocking or if I'm attacking, then it's going to go through this and it's going to check for these things. Am I moving or not? All right, so none of this code before this blend poses by bool that checks for if I'm attacking or blocking, none of this is going to play if I'm not attacking or blocking. All right, it's just the main cache is going to go straight into the true pose. I'm not attacking, I'm not blocking, and then it's going to go forward with the code. And if I am attacking or blocking, then I am going to check for velocity. I'm going to check if I'm blocking. Those kind of things. Okay. And I'll just move this down to kind of be more in line with that. So we skip this if we're, and then I'm going to fix this right here too. All right. Just for my own OCD. All right. All right, and this enemy is using a state tree. And you add a state tree by adding the component on the left. like you add other components, and then once you add that component, you have to you click on the state tree component, and then you go down on the right and you make sure that add the state tree that you created. In my case, it's st underscore enemy queen. So just real quick, I'm not going to go into this too much, but I'm having an idle, and I'm doing some conditions like if the location is less than or equal to 150, like if I'm less than that distance away from the player, then I will go into attacking. And if it's greater than that, then I will go to move to player. And moving to player, if our player is attacking, then we will move to attack player. So these are transitions and conditions. The state tree checks for conditions. Well, the state tree has transitions, and the transitions check for a condition, and if that condition is met, it moves to that new state. So, and then you have a context actor inside of your task, and you make sure that is instance editable and invisible, so that you can access those variables inside of the state tree. This is a very quick overview of this, and I don't blame you if you don't understand what's going on. On the left here, what we do is we have a schema, and then we have a context actor. And the context actor, you see that drop down below schema where it says state tree component, where it says Quang. On that drop down, you just go select the actor or the blueprint that is implementing this state tree, and then it becomes the context actor, and then you can access its variables on the right with the tasks and the transitions. So from idle, we have two transitions. We go to moving the player or to attacking the player. So if we go to moving to player if our distance is less than 1,000 and greater than 150. Then we will try to move to the player. If the player gets outside of that range, if it's greater than 1,000, he'll just stop. He'll just go back to idle. Otherwise, if it's in that range from 1,000 to 150, then he'll move to the player. And if it's less than 150, then he'll go to attacking the player. All right, and what the attack player does is it just implements the attack, and then it goes back to idle essentially, and it happens on tick. So it just checks the distance again, and if it's still under 150, it's going to attack again, and it happens so quickly that you're still going to be able to move on to your next combo. And it's just implementing this interface here, attack actor. And that's what I'm using in the enemy character. This attack actor, that's what kicks everything off. And it just fires that again if the distance to the player is less than 150. And this is an implemented interface on class settings. Again, you go to class settings, implemented interfaces, and you add it there. Now I have my enemy, he has a different interface than my player. You might get to the point where a lot of those things start to overlap. You might have some overlapping functions, and so what you might want to do is you might want to combine some of those and have it one interface that both character and enemy implement, and then for more specific functions you have an enemy interface and a player interface for those more specific functions. So you can implement multiple interfaces. In this move to player, so you could put these inside of the state tree task. You could put the attack stuff in here and just not implement it on the enemy. It's kind of a personal preference. So this is for the stamina bar. just what I'm doing with the stamina bar. I'm using a progress bar, and I put that in a border, and the border is in an overlay. And so you might think that you change the color by going to the black background image and stuff, but no, what you want to do is this is not where you change the color. You go down below progress to appearance, fill color and opacity. That's where you change the color of your stamina. And then for the percentage for the progress bar, what you want to do is you want to bind that, or create a binding, and you do that by click. There will be a chain next to this percentage, and you click on that and you select create binding, and that will create a function inside of your widget that I already have open that you can add some code to, and it will change your stamina bar based on that. And this basically checks on tick as well. So if your stamina value changes, the widget will update. And what I'm doing is I'm doing a map range clamped, because the progress bar is a value between 0 and 1. That's the way the widget progress bar works. So what this map range clamped node does is it takes an in range from 0, in range A and in range B. So essentially that's your min and your max. So 0 is our minimum, our max is our max stamina. And what that does is it converts that to a value between 0 and 1, so that the percentage bar is intact, and is shooting out the correct percentage. For example, if the range was from 0 to 750, and the current stamina is 400, it's going to calculate that and give you a correct percentage between 0 and 1. And then you just have that return value go into the return node, and the progress bar will be updated correctly. All right, so that's a good way. I've seen other people, just divide these values by 100 rather than use this map range clamp node. And I think this is just a much more straightforward way of doing that. And this is a value between 0 and 1. Again, you create binding by clicking on that little kind of chain. Excuse me. I'm implementing the stamina widget off of the child class, because if I did it on the base class, then any character that used the sandbox base character would add the widget, and I only want to add it on the player class that I'm using, so that's why it's being added on the child class rather than the base class. Alright, so for the special effects, I'm using the Paragon character's lightning burst, just to have some kind of effect play when we get a perfect block. It's probably not it's probably a little overboard for our purposes, but it's just to kind of show, to add a little flavor. And then I just want to show you real quick how I created the blocking animations, was blocked animation, kind of like the enemy hit your sword and it's kind of a little bit of a recoil. So what I'm doing is I'm just have a new level, and I'm going to create a new level sequence, add level sequence, and then I'm going to add this static mesh, or skeletal mesh, and I'm going to go look for an animation, and I'm just going to duplicate it for my purposes. I'm going to duplicate it for my purposes just because I don't want to mess up this animation. And I'm going to remove the frames essentially somewhere in between the beginning and the end of that anim notify state. And I'm just going to name this. I'm going to duplicate the animation, I'm duplicating the animation, not the montage, and I'm just going to call it something like test block or block test. And then where our player is going to be hitting block, that's where we want the recoil to start at. And I'm just going to do it somewhere in between. I'm going to check. And what you do is you right click as you get closer to the left. the remove frames and range gets smaller. So I'll start from remove 6 and on. That's a little bit too early, so I'm going to undo that, Control Z, and I'm going to go further to the right on that bottom area. I'm right clicking and I'm going to remove frames and range from 7. So where I'm right clicking is down where those controls are, like where the record is, where you can kind of scrub the timeline. That's where I'm right clicking, and I'm getting that option to remove frames. So if you are all the way to the left and you right click, it'll be like remove frames from 0 to the end of the timeline. And if you're all the way to the right and you right click down there, it'll be like remove frame 30 and 31 kind of thing. All right, so this looks good to me. So I'm going to save this animation. And I'm going to drop this animation right here. I just added that, I clicked on the plus on the animation. And then I'm going to hold Alt and click on that animation and drag to make a copy. And I'm going to right click that copy, and I'm going to go to animation, down to playback, and I'm going to reverse it. All right, so this is very basic. It plays the same animation in reverse to give the illusion of kind of I'm clanking off of the sword. Now, you can change the end of the animation. Well, actually, before I get to that, now that we have this, if you drag the one animation into the other, it starts to do a blending. But I don't like I didn't like the look of that. So what I'm doing is I'm checking where that animation ends, and it says it goes to 12. So I'm just going to go down to my timeline, type in frame 12, and then that's where I'm going to end the animation. Just drag this out, and I'll hit the red bracket, and that will automatically end the animation at where I am at in the timeline. All right, and now what I do is I want to bake this to a control rig, so I need to click on Quang, and I need to bake to control rig from there, from the actual skeleton, not the animation or the timeline. So bake to FK control rig. I'm just going to use an FK for now because I'm not going to actually edit the animation. So FK control rig is just fine. So I reduce keys and then I hit create. And now that it's baked to a control rig, I can delete that animation out. So I can just remove that from the sequence. And to get the bones to disappear, I need to click on one of the controls inside of the control rig and then hit T. So I can't be clicked on Quang, I can't be clicked on FK control rig. It has to actually be one of the controls in the sequence. I click on that, and then I hit T, and that shows and removes bones. Or controls, actually. Which in this case are bones. Alright, so now that we have an animation that looks okay, again, we need to click on the Quang skeleton, and then that will give us the option to bake animation sequence. And then we just bake it. And we can name it whatever we like, just to see that it works. Okay, so if I'm going to show you how the blocking works, this one is if he's interrupted, or yeah, if his combo is interrupted. This is like if it's just a regular player. If I do a perfect block, he'll just restart his combo. Okay, and this is what it is if he doesn't restart his combo. He just moves through his combos, and you can continue to try to block. And you see if I mess up the block, that I lose stamina. Alright, so there you go. Hopefully you learned something here. Hopefully, I know I didn't go step by step like I normally do, so I hope that this works for you and that you're still able to utilize this. I hope you learned something. Thanks for stopping by. You take care.